Good morning, everyone. Myself, Aditya Chauhan, and teammate Malobika Paul are going to present SQL versus NoSQL presentation.
So, what is a database? A database is an organized collection of information which manages data efficiently and allows users to perform multiple tasks with ease. SQL stands for Structured Query Language. It is the most commonly used relational database language today. It's a tool to retrieve the required information from database. Various examples are IBM DB2, PostgreSQL, and Oracle. There are four SQL language statements. First is DML, which stands for Data Manipulation Language. It is used to retrieve, store, modify, delete, insert, and update data in database. They are select, update, and insert. The second is DDL, which stands for Data Definition Language. It is used to create and modify the structure of database objects in database. Examples are create, alter, drop. Alter modifies the schema of the table and drop deletes the whole table. Third is DCL, which stands for Data Control Language. It is used to create roles, permissions, and referential integrity, as well as it is used to control access to data. The statements are grant and revoke. Grant command is used to provide an access or privileges on the database objects to the users. Revoke command removes users' access right or privileges to the database objects. Fourth is TCL, which stands for Transactional Control Language. It is used to manage different transactions occurring within a database. The statements are commit and rollback. Committing a transaction means making permanent changes performed by the SQL statements within the transaction, and you can use rollback transaction to erase all the data modifications made from the start of transaction or to a save point.
On the left side of the page is the basic syntax of an SQL query. A select statement retrieves 0 or more rows from one or more database tables or database views. Inside a table, a column often contains many duplicate values, and sometimes you only want to list the different values, which can be done by distinct keyword. From clause is used to list the tables. A join clause is used to combine rows from two or more tables based on a related column between them. The where clause is used to filter records. It is used to extract only those records that fulfill a specified condition. The SQL group by clause can be used in a select statement to collect data across multiple records and group the results by one or more columns. Having command filters records that work on a summarized group by results. The order by keyword is used to sort the result set in ascending or descending order. As soon as you execute the query, from and join clause are executed first, followed by where clause, group by clause, having clause, select clause, distinct clause, and order by clause.
NoSQL stands for Not Only SQL. It's a class of non-relational data storage systems which doesn't require a fixed table schema, nor do they use the concept of joins. Various examples are MongoDB, Amazon DynamoDB, Cassandra. Let's understand the concept of NoSQL through its implementation in Amazon DynamoDB.
When you're building an application, you want it to run fast, and you want it to stay fast as your business grows and more people use your app. Databases have always been one of the biggest challenges in scaling these applications. Most databases just weren't designed to match the scale and performance needs of modern apps. As more and more people use your app, and you add more and more web servers, the database layer often can't keep up. It gets slower and sometimes fails, taking your application down with it. You can try to get around this problem by building a large cluster of databases. This can work for a while, but it's hard and expensive and requires a lot of expertise. You have to make sure your database keeps running and data isn't lost, even if one of your servers goes down or there's a problem with one of your data centers. You have to know what to do if your application grows so fast that your cluster is no longer big enough. And you have to make sure your databases are running the latest software and be ready to patch or upgrade this software without shutting down your business. What if you could replace all this complex software and hardware with a database service designed from the ground up to support the low latency, high throughput requirements of today's high-scale applications. Introducing Amazon DynamoDB, a high-performance, non-relational database service built for the cloud. DynamoDB is very easy to use. You can forget about all the problems that come with managing your own software and infrastructure. That's because DynamoDB isn't database software. It's a database service that handles all of this for you. You just tell the service how many requests it needs to be able to handle per second, and it does the rest automatically. Then, when your application really takes off, and your database now needs to be able to handle thousands or even hundreds of thousands of more requests, what do? You just dial in the scale that you want, and that's it. We automatically spread your data across enough hardware to provide consistent performance and to protect against downtime.
NoSQL databases try to offer certain functionality that more traditional relational database management systems do not. First is key value based. These type of databases work by matching keys with values similar to a dictionary. There is no structure nor relation. After connecting to the database server, an application can state a key and provide a matching value which can later be retrieved the same way by supplying the key. Second is column-based. Column-based NoSQL database management systems work by advancing the simple nature of key value-based ones. These databases are commonly used when simple key value pairs are not enough. Third is document-based. Documents overcome the constraints of one or two level of key value nesting of columnar databases. Last is graph-based. The graph-based DBMS models represents the data in a completely different way than the previous three models. They use tree-like structures with nodes and edges connecting each other through relations.
This is a key value-based NoSQL database management system. The MongoDB consists of 4 operations. First is create operation, which adds new documents to a collection. If the collection does not currently exist, insert operations will create the collection. You may enter one or many values at a time. Insert one and insert many commands are used to insert the values. Read operation retrieves documents from a collection. Find command is used to read the data from the collection. Third is update. Update operations modify existing documents in a collection. Update one, update many, and replace one commands are used to update the data. Delete operation removes documents from a
SQL is a relational database management system and has predefined schema and works on tables, whereas NoSQL is a non-relational database management system and has dynamic schema and works on key value pair, graph, document, and white columns. SQL databases are vertically scalable, which means that traffic load can be managed by increasing the CPU, RAM on a single server. On the other hand, NoSQL databases are horizontally scalable. You can just add few more servers easily in your NoSQL database infrastructure to handle the large traffic. For properties, SQL databases emphasize on ACID, whereas NoSQL database follows Brewer's cap theorem. Atomicity is an all or none proposition. Consistency guarantees that a transaction never leaves your database in a half-finished state. Isolation keeps transactions separated from each other until they are finished. Durability guarantees that the database will keep track of pending changes in such a way that the server can recover from an abnormal termination. Properties of NoSQL. Consistency. Every read would get you the most recent write. Availability confirms that every node always executes queries. Partition tolerance confirms that even if the connections between nodes are down, the other two promises are kept.